All right, I'm going to do chapter 3, number 22. In this one, they give it to us differently. They give it to us as cardinal directions, south of east, north, south of west. So they gave us these three vectors, and what they're asking for is they want you to draw them on a diagram, which we'll do that. Then they want to find out the components, and then we want to find a vector D, which is equal to A plus B plus C. And we want to find that as a magnitude and a direction, because that's what they gave these as a magnitude and direction. So the first thing we're going to do is we're going to draw our graph here. In this case, we don't have x's and y's. We have cardinal directions: north, east, south, west. So the first one says 3 meters, 20 degrees south of east. You always got to remember that the last one they give you is the reference. So east is our reference, and 20 degrees south means you go south of that. So we're going to go like this, a distance of 3 meters. So this is 3 meters, this is vector A, and this angle here is 20 degrees. See how it's 20 degrees south of east. Okay, vector B is 2 meters north. So we go like this, it is 2 meters straight north. And then vector C is 5 meters, 70 degrees south of west. Here's west, south of west would be down, so it's going to go at an angle like this, so that angle is 70 degrees. This is 5 meters. And that is a representation, graphical representation of these three vectors. Now what we do to add these is we got to do it in components form. So we need the components of all these. So remember, the components we have is we want AX here, we want AY here, we want CX here, and CY here. And we don't have to do components of B because it's already on the axis. So we're going to say that AX is going to be equal to, so we look over here and we say, oh, here's our 20 degrees, that's the adjacent side. So this is going to be 3 times the cosine of 20 degrees. And notice it's positive. AY is going to be negative 3 sine of 20 degrees. Why is it negative? Because the y component is going down. Bx is equal to 0. By is equal to 2. Then Cx, is this one here, is going to be negative, and it's going to be adjacent, so this is going to be cosine, so this is negative 5 cosine of 70 degrees. And Cy is going to be equal to negative 5 sine of 70 degrees. Notice it's also in the negative direction. So really be careful about when you do your signs here. You got to get your signs all right. Then to figure out what D is, we do x and y separately. So we're going to do dx is equal to ax plus bx plus cx. Or dx is going to be equal to, here's ax, it's going to be 3 cosine 20 plus 0. I don't really have to write in there, plus cx, but this is plus, so it's going to be plus and negative, so it's minus 5 cosine of 70 degrees. And when I do that, I calculate that dx is equal to 1.1 meters. dy is going to be equal to ay plus by plus cy. Well, ay is here, so this is negative 3 sine of 20 plus 2, that's what by is, minus 5 sine of 70. And when you calculate that out, you get dy is equal to minus 3.7 meters. Okay, so now we have the components, x and y, but we want to figure out what d is. And if I was going to draw this right now, this would be the easiest time to draw it. So let's draw this on here. 1.1, we're going to go over 1.1, but we're going to go down minus 3.7. So let me do this in black here. So it's going to go here, down to about here. So this is vector d, right there. Okay, but what we want this is magnitude and direction. So the magnitude of d is the square root of x 1.1 squared plus 3.7 squared. See how I leave out the negative? It doesn't matter because you're going to square it, that negative is going to go away anyway. And when you calculate that, you get d is a distance of 3.9 meters. And the angle is the inverse tangent of the opposite over the adjacent. So I'm going to do this angle here. So I'm going to do dx over dy. So in this case, dx is 1.1 over 3.7. You could do it the other way if you want. It doesn't matter how you measure it. So if you do it this way, you get an answer of 16.6 degrees. Okay, but 16.6 degrees, remember I did it so I calculated this angle right here. That's my theta. And when I did this, because this is dx down here, this is dy over here. So now I have to tell it where that is. Well, my reference point is going to be south, but I'm going to be east of south, so it's 16.6 degrees east of south. So those are my two answers. There's the magnitude, there's the direction. And that's how you do number 22.